In this video, we're going to look at how Pliant can automate the configuration of the F5 Big IP load balancer to support a web-based application. The world has moved away from using unencrypted web applications, which typically use the HTTP protocol, in favor of more secure HTTPS protocol, which uses SSL or TLS as the encryption layer. To perform this encryption, we use SSL certificates utilizing something called public key cryptography. This particular kind of cryptography harnesses the power of two keys, a public key and a private key, which are long strings of randomly generated numbers. As part of the configuration process, these keys need to be generated and installed on the server. The F5 Big IP is capable of performing what we call SSL offload. Rather than install a certificate on each web server, you install the certificate on the Big IP itself. This reduces configuration complexity and saves on the number of certificates you need to create and install. It also reduces the overhead on the servers, as now they don't have to encrypt and de-encrypt traffic in addition to serving up web content. As you can see, there's a great deal of complexity and configuration that must happen to make all of this work correctly, and Pliant can automate all of it. Pliant's low-code UI contains all of the action blocks you need to interact with your F5 Big IP load balancer and your CA server to configure all of this for you. We're going to show you a series of pre-built Pliant workflows that perform all the necessary steps to build out your HTTPS application. The first thing we need is a certificate from our CA server. There are several steps needed to accomplish this. In Pliant, we execute a series of action blocks to tell the Big IP to create the new private key. Then in a second series of action blocks to create the CSR, or certificate signing request, on the F5 load balancer. Once the CSR is created, we use a workflow to send the CSR to the CA server, which returns us a signed certificate. Using some more action blocks, we install the signed certificate on the Big IP and create a new client SSL profile using that certificate. Now we're ready to use the F5 declarative language AS3 to finish our configuration. Using a couple more action blocks, we'll generate the AS3 file, which will configure the following on the Big IP load balancer. We'll configure a virtual server or VIP, a server pool for the real servers. We'll configure the real servers. We'll create a source NAT pool, or SNAT for inbound IP address translation. We'll apply an SSL client profile that we created and put on the box earlier. Then we'll retrieve an XML file and apply the appropriate Web Application Firewall or WAF rules. Going and retrieving the XML file ensures that no matter how many F5 Big IP boxes we put this application on, they all will have consistent protection. I'm now going to demonstrate how automation can save time and effort. As you can see, I've sped up time about 10x for this part of the video as I work through the manual configuration of an HTTPS application on the F5 Big IP. The steps are the same as in the beginning of this video. I need to generate a CSR on the F5 and take the request and paste it into the Microsoft CA server to generate my cert. I then need to download the cert from the server and upload the cert and the key to the F5. I will then build out a client SSL profile. Build a snap pool, build a pool with my two server nodes, and then build my virtual server, including the client SSL profile and the snap pool. Lastly, I will download the XML file for the application security definition I need for my Web Application Firewall or WAF. As you can see, it took about 9 minutes and 40 seconds to configure the Big IP. Very quickly, we can see that the configuration is complete and the web page loads. All of this can be done with a set of workflows in Pliant. I'm going to run the HTTPS application build workflow with the following inputs. Notice that we are operating now in real time. I'm going to log in, select the workflow, and input the same information I used when building this out manually on the F5 Big IP. I'm going to put in the web pool name, which will be Pliant Demo Pool. I'm going to have my FQDN be demo1.pliant.lab. I'm going to specify my pool members as .120 and .121. I'm then going to specify my VIP address, the server port for the real servers as port 80, the tenant that all of this will be configured under, and then I'm going to specify the location of the XML file that contains the WAF policies. This is located on my server and will be pulled over and instantiated as part of the workflow. Now let's execute this workflow. Every workflow built in Pliant automatically builds a RESTful endpoint that you can call from any other platform. In our case, we have a small web page called Trigger that authenticates to Pliant and allows us to run any workflow we wish, which is what I've been using to put in the information. When this finishes, we'll go take a look at the actual workflow blocks that were used to build out this application. You can see under Output Variables that our automation has configured everything for us. Time from login to application, 1 minute and 19 seconds. That's about a 10x savings over what it took me to do it by hand, and that's assuming as an end user you know exactly what to do, how to do it, and you get each of the steps right every time. Let's log into the Pliant platform and look at how this was done. On the main dashboard, we see a graph on how many workflows have completed in the last 24 hours and how many have completed in the last 5 minutes. If we select the F5 build HTTPS application workflow from the log entry, you can see the type of information we log for security and governance. We show who ran the flow, in this case demo. We have the start time, the end time, and a UUID that can be used to search for the log entry later if necessary. We also log the output information from the workflow so you know what has happened. Now let's take a quick look at the Pliant Workflow Builder and the blocks we use to build out this application. Here are the blocks we use to build out the workflow. This workflow calls a series of other workflows which complete each of the steps we saw performed. If we toggle back over to the F5, we'll see our virtual server is green and ready to use, and our pool members are ready to serve up content. Using a new browser window, we'll type in the HTTPS address and see our web page. If we click on the lock, we can see more information about our cert. Note the address is from our CA server in the lab. Pliant is a low-code solution that provides drag-and-drop building blocks, or action blocks as we like to call them, for hundreds of different vendors, enabling our users to quickly and easily build complicated workflows like the one in this video. Pliant allows you to build integrations in minutes, not hours, days, or weeks.